Okay, so hello everybody. So this little introduction on speech we will see later from Professor Philippe, Professor Dr. Philippe Yuan. And as an introduction to this week, so my name is Thomas Je଀erson. I'm a teacher at Versailles University and at Bartlett in London. But this week we are organizing a workshop in Versailles with my students from the third year in architecture. And for that reason, or for that occasion, we created also a lecture series that goes together with some of our research that we are doing together with Stéphane Berthier and myself in the research lab called Le Havre. It's the research lab from the University of Versailles. You will see that this week and these events are organized together with Caramba 3D, thanks to Clemens Preisinger and his team, and also the people from Octopus with Robert Fielinger to help us in this event. Also the people from Bonning & Grohmann, which I have to be very thankful for their help, and the University of Versailles, of course. So why this seminar this week? First of all, because indeed our students are working in this digital environment, and we thought it could be interesting to talk about these things. And lately I've come back to one of these images that I found when I was doing some research for a conference that I was about to give on Jean Prouvé. And he was talking a lot about the essence of material. And to be fair, Jean Prouvé neither has or had a degree in architecture nor in engineering, whereas most of the people really know him quite well as a builder. And so there's a couple of remarkable things that he said during his lifetime, that it's the current drama is the bad use of materials and structures, or that an architectural practice is not conceivable beyond the factory of fabrication with materials, for example. So these are two quite remarkable statements for somebody that built himself so much. And I think in the light of the developments that we had the last 30 years and with the digital fabrication, with fabrication an sich, and the democratization of fabrication, so that people conceiving structures and architecture can actually go and refer back directly to the material world. So that's one part, and that's because these digital tools, either whether it be just the computer that is helping calculations, but whether it be also the direct machines in factory, are getting closer to the designer again and being used in fab labs throughout schools nowadays in architecture as a new means of conception. The other part is that the material part, because of ecological thinking and people interesting themselves in, again, ancient materials, the use and fabrication of these, their mechanical properties, is getting back to the conception table too. So if you look at earth or stone, for that matter, which are really quite in a hype now, it's all coming back to the designer. So this remarks from Jean Prouvé seem very accurate and to our current development. We have Paul Emmanuel with us that is also working himself a lot on this topic, so I'm rather happy to see him here today. And that's why we started to talk about experience and experimentation. You see, it wasn't unusual back in the days, because the codes were not covering all the things, that we had to test many of the productions and the buildings that we were about to do, even to go and find more optimal solutions and more ecological solutions. And I think this whole thing with robotic design of today brings it back to the table also, that we should think like, what is their input? What can we do with it? What do we need to think about it? How can we be critical about it? And what do we do for the future about it? So I've written this text. I will not leave it too long. It's also, you find it back on the website that we created. but it talks about also what should we do as teachers, what should we do as builders for the future, how should we integrate this thinking, how should we integrate optimization and material knowledge, and how does this come back actually this experimental digital approach. It's about creating experience and experimentation, building one-to-one scale already for students. How does it go back to research too, basically? So there's many questions to be asked, and some of these will be answered throughout the lectures that we see this week. So happy to discuss also afterwards with you guys. I've brought some samples from recent work where I've been thinking about this, of course. And one of them is, of course, with Thomas Jeắ�erson, with whom we've worked extensively over the years. And this is one of the very complex projects that we've been working on. And I remember this model in his atelier in Berlin, where he constantly worked on a scale 1 to 5, but even almost 1 to 1 for certain parts. And it was building up experience. And by experimenting how it would work, that he would find forms, which was very complex also to model and to really make a preview for the reality. So the learning by making, so we've done one of the workshops in previous years in 2018 was with Thomas Jeʀerson, and our students explored many design solutions, which were checked back with the team from Thomas and Thomas himself. And either it was both digitally and both physically, and I think it has a huge impact, in my opinion, for students to know and see what they can reach with the testing of physical realities, but checking it back with the digital reality, and with the digital reality to bring it to a further stage, if possible, for that matter. Here we tested with Thomas in our own courtyard here in Paris, also some structures that was at the beginning of the workshop, so testing it really, and exploring by physically and digitally modeling the things. So this was a very fine example, I think, for the students how to learn. I go quite fast, I'm not making it too long, but I think this is one part where I want to reflect on in this series of lectures is how do we, as teachers, work this out for our students in the future. This, maybe it's a new paradigm, maybe not, and how do we use it in our advantage? The other one that we tested with students last year in the confinement, actually, which was a bit complicated, but also with manufacturers really from SICA here for that matter. So students all designed different columns. So it's, of course, it's a structural exercise in a certain way, but also a geometrical one and an aesthetical one. And SICA then printed it. So immediately working with the manufacturer that is going to make, you just decide on the robot what he's going to do, bringing in the robotic realities into design reality or around. So this was basically working after we had tested already with X3 some of the stuff here in my own practice. And there you see it also bringing from the praxis back things into the university, from the university back into the reality and the built world. And how do these things work together? I have a bad example where nowadays, if you see with the vaccination, most of them, or a couple of them, are realized together with universities in the UK, for example. But at the moment, French universities have no say in the development of vaccinations. So where is this world where we find each other back from university back into the reality? And I'm Belgian, so I had to show this example. Working with robots, my students need to make Japanese joinery. And of course, I told them, because they were all in confinement, they could do it then by cutting by hand some potatoes. I'm dreaming now of making one series of these potatoes as Belgian fries, of course, but okay, that's going to take some time, possibly. And again, also looking in other domains. These are some of my students at the Bartlett, where I did a patisserie course, and bringing this whole development of patisserie into a real pavilion building. So it's industrialized, it's fabrication, it's one-to-one, and bringing it back as a kind of teaching method. It goes further into build projects, which here with Rirti Tiravanija, with bamboo, where you see there's a whole problem of these things. Bamboo is not an easy material. And so even in the built world, we can go back to experimenting. And you see here the only way how we could do it ourselves, because you don't have the values, the real values of the bamboo, and plus the security margins are too big. So you go and test it yourself, basically. And I think, again, this is some methods that might get a larger chunk of responsibility in the future building. And this even went on into doing research, which we are currently doing on joints filled with mortar for bamboo. So this is an ongoing research. So happy if anyone wants to join in that. So we're happy to see you further. It all comes down to bringing these things, performance, fabrication, materials, structural form, into an integral design process, I believe, and to set it up not in a linear process, but that they are actually in a wider circular field, that things are coming back and overlapping the other one. And this is where we need to test ourselves. I just want to end with this one. We also have some dissertation methods in the 4th and 5th year of Versailles, where we see students to work on experimental approach for finding new ways of making architecture. And this resulted already in a startup, SAS Minimum, which does recycling of plastics and is now a big player in even providing chairs for the Olympics. And then here another student, Jeομμerson, who worked on some new materials and making structures with that. So I think here it's all about bringing this experimentation back to research, but back to manufacture, back into the real world. I think it has a large field of application. It has large possibilities and large interests. It's fun also, to be honest. And I think the next speakers, so Professor Dr. Philippe Yuan, Tom Swilans, Jacques Onglan, Areti Markopoulou from IAC, and then Oliver Wilton and Matthew Barn-Howland are all very able persons to reflect on these points and to tell us a little bit more, how do they perceive and what do they see in the world now of today, how should we continue and how should we think. So let me bring you to the speaker of today, Professor Philippe Yuan, so Associate Dean at the university, at one of the best, or actually the top university in China, at Tongji University. He's a tenured professor of the College of Architecture and Urban Planning, visiting professor at Massachusetts Institute of Technology, and Thomas Jeομμerson, professor at University of Virginia. He also founded, I mean, I don't know how you do it, Philippe, but it's true. I've seen it with my own eyes, but he has and is running 2 other Shanghai-based firms. So Archi-Union Architects, so an architectural practice, and the Fab-Union technology. For those who visited some of the Venice Biennale in the last couple of years, you might have seen some work of Philippe at the Venice Biennale. He is also a member in the scientific committee of the IASS, all known. Everybody knows the IASS, probably, originally founded by Toroja, and also in the International Conference on 3D Printing and Transportation, 3D Printing and Transportation. His current research, he has a big research lab that he has a lot of researchers with him, and that involves the implementation of prototypical methods and advanced manufacturing techniques, and focuses on how digital tools offer the possibility of a new authorship for today's architects based on an understanding of culture, materials, and built environment. So even local resources that are used in his research. So the research theories are recognizable in many of his architectural practices. So the Fab-Union space, please do visit it in Shanghai, fantastic building. Quiché in Shanghai, in Bamboo, also in Sichuan, Inkstone House in Sichuan too, and the Light of Internet Expo Center. Please do buy his books, check it out, it's fantastic. I'm very proud to have you, Philippe, today. It's a great honor, and it's, yeah, I'm looking forward to your speech, actually. I will leave the word to you. I hope it works for screening, for sharing your screen. I will check if I can put mine for the moment. Hang on. So, yeah, a big applause. Welcome.
Hi, can you hear me?
Yeah, I hear you loud and clear. I leave the stage to you, Philippe.
Yeah. It's a great honor to be invited to make a special speech in opening of the Intelligent Fabrication Workshop. So class, it's a great thanks for your invitation. And also it's a great honor for me to present what I have done right now in Shanghai. And also I want to talk about, make introduction of what we're doing in Digital Futures. Digital Futures is a special event we actually set up 10 years ago. So this is the 11th year for the Futures workshops. And also we have international PhD program and international conference. It's a great honor for me to invite, including Arati today. She's here and she also will teach in our PhD courses. So over the past 10 years, actually we have different topic every year, and the Digital Future groups growing very fast. From at the very beginning, probably we have only like 30, 40 people participate to the workshops and the conference. And then last year, actually we'll have more than 9,000 people actually apply for the workshops. This year we have the number around 7,000 people from all over the world apply for more than 100 workshops. So this year, more than 100 workshops actually organized by 10 hubs around the world, including United States and South America, including Africa, Asia, and Europe as well. So it is right now, it's like distributed association. And the most importantly is actually this is totally free for the special vision set up by Newlich and me from 10 years ago. We want to set up a certain kind of open source learning platform for all of the world. And that means, for example, the students from China, actually it's really difficult to travel to the States or to Europe, but they have a special opportunity to learning from the most important figures in the world and learning from them, from the lectures and the workshops. I think it's will helping a lot of people to have find a certain kind of inclusive opportunities to learning from the most avant-garde around the world. And our actually association invited the people from different universities, associations, institutions, and different design office, including, I think you can see, this is actually information from last year. It's all over the world. A lot of people participate, and we have different voice from the United States, from China, from Europe, from Russia, and from Australia. I think it's very interesting to set up certain kind of platform. So this year, we already kicked off 2 days ago. We invited Zizak to give a keynote speech in the opening of the PhD courses, classes. And this morning, Stanford Quinter from New York City gave another keynote speech. And the next few days, we already have different very interesting talks on YouTube. You can check digitalfutures.org. That is a very interesting platform for different people. We have a lot of discussions, and also we have workshops which will start from the end of this week, Friday. And the workshop will last 9 days. And every year we have a lot of different productions. That is super interesting. And this year, because of the COVID-19, we have a distributed platform for workshops. In Shanghai, we organize around 15 workshops, especially from Asia. And half of them come to Shanghai, but half of them stay in different countries, including India, including Japan, including different Hong Kong, Korea. And we'll share our teaching through the website, internet, and also we have different hubs in Europe and also in South America, in the United States. So that is spreading out, and 24 hours round and around in the 9 days. So I think it's great opportunities to learning from each other, to learning from the new knowledge from each other. And also that's a great opportunity to present, to all of you and class. I'm looking forward in the future we can have a very interesting collaboration between our two teams. And over the past 10 years or over the past 7 years, we have a lot of different practice research on timber. So this is we have some overlook to organize all the workshops in the past 6-7 years, around 7 workshops, especially focused on the timber structure. And from 2014 to 2020, every year we have different tests. I think it's kind of experimental research process. I invite Archimangus, ICD, and they actually came to Shanghai more than 6 times to participate in different workshops. And we have 2 different pavilions coming out. You can see 2017, we collaborate with each other and making a sawn timber shell in Shenzhen. I think that is extremely interesting for the opening of a new museum in Shekou, Shenzhen. And the pavilion was collected by the new museum there. And also last year, although the COVID makes it impossible to make a physical workshop, but actually Achim's team and the DDRC, which is my research team, we actually make the last pavilion here. You can see in the COVID-19 time. And also, I think the special things I want to mention, I think workshop is not only just the motivation for the research. I actually set up Archi-Union and Fab-Union as 2 different research on practice platform, which actually introduce different new technology to the real different scenarios in China. So actually we have 7 projects, which is especially deploy the robotic fabrication technology and implement these the new technology into the real projects. So that's also 7 projects. So I don't know how long you give to me, but I want to have a very quick overview of some of these workshops and projects in a very short time to present the special relationship, the special integration between the research, experimental things, and also how to transfer this kind of technology into the real project.
We have all the time you want, Philippe. So
okay.
It's a pleasure to listen. Yeah. So don't worry.
Okay, because today maybe the topic is special on wood. So wood is a fascinating building material over the history of China, actually. And we especially have dogong, which is kind of joints with no nails. Over the past 5,000 years, the Asian China, we have a lot of different kind of scenarios to make use of wood, actually. And as to the environmental special background, all of us know wood is a very good worldwide material, because not only could be a construction material, but also in the sustainable process of the growing process of wood, which can also be very important to make a full understanding and implementation in the future for our industry, architecture industry. So, and here also the wood, because of the wood have very special growing process. So how to make a full use of the material? We have different kind of scenarios and topics to make research to make a full use of the wood performance based on the material itself. So, and that is a special background. And also industry is growing super fast, not only in Europe, in Japan, and also in China as well, for the modern wood production products, which actually booming over the past 10 years around the world. So I especially named this different age. The wooden age is 1.0, actually, and that is a rule-based and hand tools process. And the industrial age, we name it modern wood age. Actually, people start use CNC and to custom all the same joints in a super fast, super efficient process to make full use of the laminate wood, for example, the material. So CNC is the most important scenarios to make use of the timbers in the industrial age. But actually goes to the customization, and right now, I think academic will switch to the robotic fabrication, which becomes the most important scenarios to make use of laminate wood. I name it digital age, actually, which is start actually from only, I think, less than 10 years. So today, I especially want to talk about this process, as you know. So I quickly go from the old wood age to the CNC age. And right now, this is scenarios in my lab. Actually, we have a very different effectors, which actually collaborating with robotics and introduce this kind of new effectors to the industry. So which we make a full use in different kind of workshops. And most important is not only the effectors or the physical platform. The most important is the software. So over the past 7 years, we developed FU Robot, which is Rhino grasshopper-based platform. And we introduced robotic vision simulation to the control operation platform, and the architects and structural engineer can very easily control all these geometrical models to the robotic toolpaths. And the goal of FU Robot is seamlessly involving architectural geometry into the fabrication process of construction robotics. As a plugin of Rhino Grasshopper, FU Robot can efficiently realize KUKA ABB UR, and also including some local brand in China. I think right now we have more than 15 different kinds of robotics, different brands. We can play them on the FU Robot platform. And different robot toolpath planning, real-time feedback, and control is deployed on this platform. And most important right now, the team is introduce 5G this real-time feedback and control process on this platform. And we open this. You can scan scan it very easily and make full use, because the most importantly, we help the user to set up a culture of learning and sharing and collaborating platform, which will help us in the robotic rapid deployment among different fabrication scenarios. And for example, in our team, we have around like 30 different brands of robotics, but on this platform, you can find more than 60, because a lot of users upload and define their robotics on this platform. That is a very easy process for all the users to sharing their information, their gantry system, or the access, different access onto upload to this platform. We can learning from each other, sharing with each other. So that is the fundamental things we're doing, which is a software platform. So this is a small video showing last year, 2019, I was invited to teach in UVA, University of Virginia, I introduced this platform and helped them to set up their timber laboratory and introduce all these kind of bandsaw, round saw for the sewing milling. It is not only a software platform, but also a hardware integrated platform. So in around 4 months, they very quickly introduce all these kind of hardware softwares to the studios in UVA. So I think it's really helpful for the students to learning all these kind of special joints and the special hardwares in a very short time. So after the software, I want to introduce the hardware. The first is offset robotic platform we set up in 2015. And the right one is in situ. We named it 8th generation of the in situ robotics we set up last year. And this year coming the 9th generation. So every 8 months to 10 months, we update a new version of the in situ platform because different technology integrate onto the platform right now. So there's two scenarios, offsite and in situ, which help us to implement different crafts and different softwares into the big scenarios of architecture industry. So this is 2015 for the robotic platform we said. And this is last year, we introduced this platform to ICD, collaborating Make a Pavilion in the Digital Futures workshop last year. So robotic carpentry, actually, we're learning a lot of tradition craftsmanship from local people. This is two workers working with me for more than 15 years. So they are the master of carpentry in China, although not well educated. But they have very strong carpentry craftsmanship, and they teach our team, the PhD student, how to understand timber and wood material and how to understand different kind of joints. So I think this is the fundamental scenarios where we teach or we training our effectors and to simulate the workers, local workers, how they work with the timbers, how the carpentry work, and training the effectors to simulate the carpentry's work process. And this is a lot of joints. I think want to just keep it for the Asian China, and I teach my students how to simulate this kind of process, and also. Not only the timber structure is a shape grammar process, formation process, but also I think optimization is extremely important by the structure performance-based simulation softwares. For example, this one is from 4,000 bars, the numbers of bars, and we reduced number to around 840 for the spatial tower in the workshop. And also the joints are different because different pieces will have different joints with each other, and different layers of the joints have different position. So we need to categorize all these joints. This is around 1/3 of the joints, and how to custom all these joints in a super short time. So this is all joints. We have 3 cut on 1 pieces of timber bar. And so this is the robotics, right, in our university lab. So layer by layer, we put them together to deploy the robotics in all this construction process. And after that, I think we have different kinds of important scenarios. This project, the left one is a workshop opening in 2018. And 6 months later, we implement this prototype to a real project in Suzhou, nearby the Taihu Lake. So it's only 6 months is implementation of the new test in our workshop to the real project. So this is a project in Suzhou. And also the most important, the components actually is, this is the formation process is based on Karamba and the Rhino Vault. And all these joints have their special position. And if you understand in the modern timbers, you understand the joints have a steel plate in between, in the middle of these joints, because is this diagonal degree. You should passing through 2 times, twice on timber and once on the steel plate. So all these joints should be extremely accurate. Otherwise, it will be impossible to position onto the real project. And in China, normally the construction process is extremely fast. So this project, the on-site work is around 6 months, and there are more than 360 pieces of timbers, but only 2 pieces of them go back to the factory and refabricate. Most of them position super accurately because of the accurate detail making process. This is interior ceiling, you can see. And I want to introduce another project in Shanghai, the West Bund of Shanghai, which is extremely central part of China. So my office designed this building, which is a exhibition building for different kind of events in downtown. Yeah, you can see this building. So we have 3 different main exhibition room and also have 2 different semi-open space. The 2 semi-open space was specially implement the timber as a main structure for the semi-open space garden here for the whole project. So you can see, most importantly, all these ceilings, and although it's all customization, we spent only 100 days by the collaboration between Archi-Union and Fab-Union to custom the super efficient short time. So we 3D print, use plastic, 3D print another Starbucks cafe under it and make a semi-open garden under this canopy. The most important joints is this reciprocal detail, actually, which gave us the opportunity to make the whole building in very short time. You can see this is the continue, 2 pieces of this is continue plate, and this is another continue plate. So the reciprocal joints make it possible for them to position them in a super short time. Yes, this is the details. Introduce the whole project. West Bund Exhibition Center. At the very beginning, we have a lot of columns, but we optimize them by this shell structure, symmetrical shell structure. With timber and part of it, the boundary is steel structure. So this is the very important collaborative process between structural engineer and architects. We're working as a team. I think which is extremely important. Why we use robotics is because of the structural performance design, which give us a very special opportunity to find the high efficiency of the project and the easy logistic issue for how the project could be constructed in a very short time. This is the details I mentioned. Okay, another project we finished before the COVID in Shenzhen, and the curator is Karati from MIT, and he invited me to make a pavilion in Shenzhen Biennale. And this one is, we name it nomadic wood because timber structure always like a linear structure. So we try to test if it is possible to make a different looking of the timber. So this is a process how we design it and fabricate. two robotics, like two hands, have different effectors on top of them. And also we collaborating with the laminate timber industry, custom one curvature at the very beginning and try to fabricate, implement the sole to make another curvature, that is a two curvature system components. Different toolbox. You can select different tools. And the one cut around 20 minutes. And the one joint we spent around also 20 minutes. So that is process. And most importantly, the joints is important. We use no nails and no steel plate. So this is learning from the Chinese furniture. It's one joints, put them together. And after this, during the COVID-19, we got invitation to fabricate a special pavilion on the theme park, which named Happy Valley in Nanjing. So this is also a timber structure, but with some FTPE on the top of the pavilion, which is the entrance from the basement, which is a parking lot, and it goes straight from escalator, go to the you can come up to the square. So this is the process project. Timber structure. And this is the project we bring to Venice Biennale in 2018. We name is In Bamboo project. And this is the also this one. And this is all the detail drawings of In Bamboo. You can see all the customization detail drawings is like the right side. It's not the detail drawing. It's not saying to the tradition architecture drawings. So this is all this from the office to the robotic fabrication shop. So this is all the details for the whole project. So you can see the curvature of the roof system and also the spatial geometry twisting together, right? This is a real project after finished construction, which is difficult to figure out the very advanced spatial geometry based on the structure system, because all the traditional materials was deployed in this project, tiles and also the bamboo weaving facade. But the main structure is especially timber. And also we designed 9 B&B buildings, which is super small, but very interesting to introduce the trees and also a small pond in the middle of the different unit. This is another project. This year in China Pavilion, Venice Biennale, and this project is one of the most project introduced to the public right now in Venice. So we designed another building, which is also steel and timber structure building, and was finished construction in 2019. So the roof is really special for the timber structure, you see, and also the bricks are the robotic brick mansion. Because the earthquake issue and the vertical component is replaced by the steel and to make it super strong for the earthquake, but all the roof, the ceilings or the different floor panels, plates are timber structure, and including the roof is also timber structure. You can see the building like this, and in the interior walls and the furnitures was 3D printed by plastics printing for the whole project. See a small video for this. Okay, this is a new one, new project we just finished last year, at the end of last year, because the whole construction process is happened during the COVID-19. So the concept is from Philippe and also another artist from Taiping in China. So we try to design a curvature roof system, which is showing a special one tree as a garden at the entrance. So the roof, the extremely big roof, is make a special curvature spanning is like 38 square meters, and the cantilever around 16 meters. So which is extremely big structure. So we implement the cable with the timber. So that is the cable, hanging cable system and the timber structure introduced to the whole project. This is after construction of the project. So this is the lobby for the hotel, and also introduce a special big column in the middle and to support the whole roof system. You can see the whole process, how we introduce the timber collaborating with the steel structure to make the whole building. So every piece is a different curvature for the whole roof system construction process. Let's quickly see this building. This is a category we implement as a toolbox to generate the form, main structure, and semi-structure to put in between the main structure. So this is the structure performance-based optimization process to generate the whole form. And that's why we need robotics for all these kind of curvatures in the fabrication process. So this is a rendering. This is after construction. Rendering and after the construction of buildings. And also the cantilever of the roof in the entrance is extremely important. From a structure perspective, the curvature makes it very big performance for the cantilever, right? So we're learning from the paper to generate a special big cantilever. 38 meters span and 16 meters cantilever. So we use a cable, to handle the whole weight of it. So this is the before the cable, and this is impossible to support such a big, the heavy roof. And after optimization, and with a cable system, so it's passing through the simulation. So you can see this cable and the special relationship to the curvature roof on the construction site. And after the construction, see this is a super big, like the car can parking in the lobby, and also one tree sitting in the middle of the roof. When it's raining, the water will part the falling water to the pond in front of the main gate of the hotel. Yes. And also I want to introduce two collaboration between ICD and my team over the past few years. So this is the pavilion, we name as the timber folding or the plywood folding by 3 layers of the plywood, how to generate some kind of curvature shell structure. The whole pavilion was made in Shanghai around 1 month, and Ahim sent one of his PhD researchers and graduate students to Shanghai and collaborating with my team and sewing the whole pavilion. And the pavilion was collected by the museum in Shekou, Shenzhen right now. See the video. Okay. And also last year, actually, ICD and our group, we make some discussion on the multi-story timber structure, how to research on a new system, how to fabricate this kind of system, and with implementation of the in-situ robotic platform. So we actually research on the plate and how to implement a structural performance-based different toolbox to generate the layout, translate the forces into the layout of the different small pieces of timbers as a plate structure system, a plate pattern to replace the traditional floor in the architecture scenarios, different scenarios. So this is research process for the grid system and optimize networks of the floors and how the forces can flow in and different layout on the floor. So this is one of the students' work in the workshop to generate the pattern to replace the beam and find a different kind of layout of the different beams. And most importantly, we want to replace the big beam material with by the small pieces of the timber bars. So that is the motivation, how many pieces we should implement and how to put them together to laminate on-site, in situ, to replace the big beam. So this is the optimization pattern, and this is the real layout of the small timber bars on the floor plate. And most importantly, we specially design in situ robotics for not only the cutting but also for the glue application effectors, for the toolbox to make the glue put on them, and also the timber stack can feed the robotics with different components, and also the robotic should have an on-site feedback to position them super fast by different kind of sensors to position this robotics on site. So this is the conceptual process, how to fabricate one column with a big cantilever slab. Design process, and also to fabricate and put them pieces by pieces. Firstly, apply the glue, and certainly second step is put them, and also new will be reinforced all these components right now for this special floor system. And this is scenarios for design and implementation of this platform. Small video to see this building system. And this is the mock-up because the workshop is only 9 days. So actually we spent around 8 days to fabricate one column and one roof plate, and also some beams. The beams replaced by the special bars, which simulate, follow the structural performance simulation, and to try to implement the different pattern of the small pieces of the timber bars and transfer this pattern to a special plate system. So this is object we finished last year in 9 days. Although it's not big, but I think it's a very important prototype. And also the office right now, we're working on another parking